Okay, I'll go ahead and get started. Just to reiterate though, for people who just joined us, please log into Crane using a terminal like you did for previous lessons on previous days. Make sure you can do that. I'll be giving a few slides first before we get started with the hands-on stuff, so you have a few minutes to actually get that done. And then you can open up the browser window to the command history link that I have on this slide, and I'll put it in the chat one more time because people who are joining cannot see the chat history from before they joined. So, okay, so I'm going to go ahead and get started. Colin, if you want, you could start recording. Or maybe I should do that.
The recording was started when you finished talking about recording.
Oh, okay, thanks. I see that now. Alrighty. Okay, so welcome everybody. I'm Emily Fuchs. I'm an application specialist at the Helen Computing Center. And today we are going to be talking about, we'll have a couple different lessons today. The first hour is going to be dedicated to talking about data management on HCC. So that's going to be stuff like where do you store your data, how to store your data, what kinds of data should you store on HCC clusters, and how to transfer your data to and from the clusters and in between the clusters and our storage machine, which is called Attic. So I'll talk about all of those things in more detail. And then for the second hour, Colin is going to be talking about applications. So that's software, how to run software on HCC. So specifically, we use a modules system, which you saw briefly yesterday when you guys loaded the Matlab module in your job. So Colin's going to be talking all about software modules and how to use them during the second hour of the lessons today. Okay, so I already briefly mentioned this. These are the key points that I'm going to go over this morning. We have different file systems that have different quotas and are meant for storing different kinds of things. So I'll go over the details of that. And then I'll talk about different ways to transfer your files to and from Crane, and we'll do some hands-on examples with that. To and from Crane, but not just Crane, also our other clusters and our storage machine that's called Attic. Okay, so this is just a slide that sort of summarizes the different storage locations that we support. So I guess home, common, and work are file systems that all exist on Crane and Rhino, our clusters. And Attic is a separate storage service that is not accessible, directly accessible from the clusters. So this shows the storage from left to right in order of increasing ease of access to your jobs and decreasing redundancy. So for example, Attic is redundant. It's backed up in 2 different locations. And if you put something in Attic, it's meant for long-term storage. So if you put something there, it will not go away unless you delete it or you stop paying for Attic service, in which case we will keep your stuff there for a while, but you will need to pay for Attic if you want to access that data. Everything else is free for a certain quota, up to a certain quota, and then common, for example, is free up to 30 terabytes per group. But if you want more than that, you can pay for that through your group. Your group would pay for additional storage on common. But Attic is the only one that you cannot access at all unless you pay for. I believe the rates on Attic currently are about $26. I'm sorry. Was it $26 per terabyte per year? So it's fairly affordable. So I'll just talk about these things on this slide, and then I'm going to talk about them even more. Again, I will just repeat myself on the next couple slides because it's good to hear it a couple times. So Attic you can access through Globus Connect, which we will use later in this portion of the talk. And you will get an example of how to use Globus to access your files on the clusters. And you can also use it if you pay for Attic storage. You can also use Globus to access that and to transfer files to and from Attic. But you can't access it directly from the clusters. Home is accessible from the clusters, obviously. You've been using your home directory for the last few days during this workshop. The quotas on home are 20 gigabytes per user, and it's mounted on a single cluster, meaning that your home directory on Crane is different from your home directory on Rhino. So if you put something on your home directory in Crane, you will not see that on Rhino unless you also copy it there. We do daily backups of home, so it's a little bit more fault tolerant than placing something, for example, on work. It is backed up. Common is sort of in between. You can access it from your jobs, and there's a group quota of up to 30 terabytes unless you pay for additional storage. It has fairly fast access from your jobs, meaning that if you place your input and output files in Common, it should be able to access those quickly. Home, for example, is not meant for fast I/O to jobs, so don't put input and output in your home directory. It just isn't very efficient. Common is mounted on all clusters, so that's why it's called Common. Crane and Rhino both. If you put something in your Common directory on Crane, you will see that same file in your Common directory on Rhino. Common is not backed up. Work is the fastest file system for input and output to jobs. There's group quotas of 50 terabytes per group. Work is mounted on a single cluster, so Crane and Rhino work directories are different. It is not backed up at all. So if there's some issue where we have a problem with the work file system and some data is lost, we won't be able to retrieve that data for you. So any important files that you don't want to be lost should be backed up somewhere more reliable. And an important point is that work is subject to our purge policy because we can't have work filling up with too many files or it will degrade the performance. So any file that you have in work that hasn't been accessed in the past 6 months will be removed. Okay, so be aware of that. Okay, the next couple slides just reiterate what I just said. Attic is backed up in multiple locations in Lincoln and Omaha. Allocations are available for purchase. It is not mounted on the clusters, so if you have some data in Attic that you need to use for your jobs, you're going to have to transfer that data using Globus to Crane or Rhino to run your jobs on, and then take any output files and transfer them, any output files that you want to save in Attic and transfer them to Attic. And like I mentioned before, it's accessible via Globus Connect, and we'll be using Globus Connect a little bit later, and you'll see it's a pretty nice user-friendly way of transferring data to and from the clusters into Attic. This reiterates things I already discussed as well. So your home directory is /home and then your group and then your username. Likewise for work, it's /work and then your group and username, and common is /common group and username. Okay, so fairly easy to remember. That's the path to your home, work, and common directories. And a shortcut for those is $ all caps home, work, and common. Okay, so that variable when you're on the clusters in the shell is equal to this path. Home directories are 20 gigabytes per user. Work is 50 terabytes per group, and common is 30 terabytes per group unless you pay for more. Home is not intended for fast I/O for running jobs. Work is intended for fast I/O, and common can be used for I/O, but it's not as fast as work. For home, there is no purge policy and it's backed up. For work, there is a 6-month purge policy and it is not backed up. Common's kind of in between. There's no purge policy, but it is not backed up. So some examples of what you might want to store in your home directory are source code, program binaries, and configuration files and things like that that don't take up a huge amount of space. Data files for jobs or input and output data files for running jobs are things that you might want to store on work, but don't store them long term. Keep anything that you'd like to keep long term somewhere else that's backed up. And then some things that you might want to store in common are items that need to be accessed from both clusters, such as reference databases or shared data files. So there's a question in the chat, nearline data archive. It just means kind of what I discussed. It's near, so it's accessible via common. It's not that it's stored on tape and we have to like get it out of some archive, but it's not directly accessible by just a CP command on the cluster. Okay, so you have to do something. You have to actively do something using Globus to transfer it to the cluster before you use that data. Okay, so just some things to keep in mind for homework and common. You want to avoid large numbers of files, not just sizes, but numbers, because there's also limits on the number of files that you can store. So if you have millions of tiny files, you might think about zipping them up into an archive if you're not using them currently. Storage resources are finite, so be careful about what you store there and delete anything that you don't need anymore. And that just helps keep the file system healthy and fast for everybody who's using it. And of course, as I mentioned, but I'll say several times because it's very important, please back up your valuable data. We do not have any storage services that are appropriate for storing HIPAA or personally identifiable data sets. So please do not put those on our machines. Okay, let's go ahead and log into Crane if you haven't already, and we'll run a couple very short exercises here. I'm going to share my entire desktop, so I'm going to quit this and change my share for just a second here. Okay, so everybody should be able to see my entire desktop now. If you don't already have it, please open up the command history window. I'll put it one more time. I've already put it a couple times in the chat, but I'll put it in the chat again in case you would like to grab that link. Okay. So the exercise is that we should log into Crane and find out our group's disk usage, okay? So I'm logged into Crane here. I'm using the demo11 account, so that's my username. So I can type pwd and see I'm in my home directory now. So when you log in, you will automatically be in your home directory every time. So if you want to switch to your work or common directories, you have to do a cd command to do that. But let's go ahead and run this first command it asks us to do, hcc-du. Okay, so this shows up actually every time you log in by default. So you may have already seen this before. But what it does is just summarize your total disk usage at the current time. So I'm using a demo account, which has almost nothing in it right now. So you'll see that my home usage is very small. It's only 2.4 megabytes out of 20 gigabytes total. It shows what my group is using in the home directory. So the demo group is using 10 gigabytes. And then it shows what's the total usage of all the groups and users on Crane. So everybody should see the same thing for this last row. And then similarly for work and common. So that's a good way to just see at a glance what your usage is. And maybe if you're having trouble writing output, one of your jobs is having trouble writing output, and you notice that your work directory is full, that might be why. So it'd be a good idea to clean up your work directory. Okay, so let's go ahead and find out, do exercise number 2. It says find out what files are scheduled to be purged. This is anything that's been dormant for 24 weeks and is scheduled to be deleted if it's not accessed soon. So let's see. It's just HCC-purge-L. Okay, so my output is not very interesting because I'm using this demo account. But and yours may not be either. If you have a new account and you just got it set up, then you probably have nothing output here. But this is a good command to know for the future. It will print a list of all the files that you have scheduled to be purged. So it's really good to run this from time to time and make sure that anything that you want to keep is backed up somewhere. In fact, you should back it up immediately as soon as you create the file and not wait till 6 months later to do that. All right, any questions so far? Go ahead and put up your green check mark by your name if you're able to run those commands successfully, even if there was no output from that purge command. Thanks. All right, next it says to cd to our work directory and display the current path and list the contents. So that's just a cd work and then pwd to display the contents and then ls. Or I'm sorry, pwd to just display the path and then ls to display the contents. So cd $work pwd. As you can see, the path changed to work demo 11, and yours will be your username and your group, not mine. And then ls to see what's there. So here I have the job examples directory that we were using yesterday. You probably have that as well if you were at the lessons yesterday. Okay, so next it asks us to do the same thing for home and common. So I cd home, I do pwd, I see the path has changed, and then ls shows me what's in there. I currently have the stuff from the first 2 days of our lessons, the shell lesson data.zip file on the unzipped directory. So you might have that as well. Next, let's cd to common. I think there's probably nothing in here for me, but the path has changed to common demo 11, and there's nothing there. All right, any issues running those commands? Anyone get an error or no output is probably fine. It means there's nothing there. If it's the ls command and you got no output. Okay. If you want to just check the ls command is working, you can do the ls-a. That will show even your hidden files and directories. So you should at least get the dot and the dot dot. That means the current directory and the parent directory. All right, great. Let's go ahead and move on. Okay, so for people who were not here yesterday, you can go ahead and download this Git repository to your work directory. So I had that already there, but I'll go ahead and enter that command again. So I'm going to cd work, and then I do this Git clone. I just copy and pasted that, so I'll copy and paste it into the chat as well. It should also show up in the on the web page with the command history. And it's just telling me I already have it there, so that's why it didn't download it. But if you don't already have it, it should download it for you. Any issues with that step? Hopefully everybody has already got it. Okay, so we're going to talk next. Actually, before I switch gears here and talk about transferring files. Are there questions about storing files? So there's one question in the chat saying, can I do that for any directory from my desktop? So are you talking about doing Git Clone? You can, yeah, so you should, if you have Git installed, which you should, then you should be able to do a Git clone and clone something to your computer as well. So we're running it on Crane, but you should be able to clone a repository to your, so right here, I'm on my, on this terminal that you see here, I'm on my laptop here. So I'm gonna CD to my desktop and then do the Git clone again. And then I can download it to my desktop on my computer. Yep, no problem. Okay, so any other questions about storing files and where to store files on our clusters? I'll talk next about how to get your files to the clusters and from the clusters. Okay, so there's multiple different ways to transfer files, and everyone may already have their own favorite method of doing this. You can use the command line. You can run an SCP command from the terminal or command prompt of your desktop computer to transfer a file to or from the Crane, for example. And this is just the syntax for that. So it's, if I want to transfer a file, I type SCP space, my username. So this is for the source file. So it would be the username at host, and then the source file, the name and location of the source file, and then the target is the username at host, and then the target directory or file. Right. So, for example, let's say I'm running. You don't need the user at host if it's if it's local, right? So if the source file is local, it's on my laptop, and it's called myfile.txt. I don't need this user at host colon. I just give it the path to the file. If the file is not in my current directory, I would need to specify the path that it's in. And then the target. So the target's going to be Crane. It's my username at crane.unl.edu. And then where do I want to put it? I want to put it in work, demo 11. Okay. So that's an example of transferring something from your laptop to Crane. And then as I mentioned, for transferring files between the computer and the cluster, always run the scp command on your computer, not on the cluster. Okay, so let's do an exercise. If for some reason you don't have SCP installed or it's just not working on your computer, then you don't have to do this. You really don't have to use the command line to transfer files if you don't want to, because we're going to learn about another method that might be even more user-friendly for people in just a moment. That's the Globus Connect method I mentioned earlier. So if you'd like to try this out, though, please do. This terminal that I have right here is on my computer. I have not logged into Crane. I'm on my desktop, and I have several different files here, and I want to transfer one of them to Crane. So the command is scp, the name of the file. So I'm going to transfer this README file that I have here, and I'm going to transfer it to the demo account I'm using. And I'll go ahead and just put it in the work directory. It's going to ask for my username and password, of course. Or not my username. I already have the username there. It's going to ask for my password and my Duo authentication. So I just get my phone out, I click approve, and it transferred the file for me. So if I look now here on Crane and I CV to work, Maybe I'm already there. Yes, I am. So if I do ls, now I see this README file has been transferred from my laptop. Okay. So if you guys want to grab a file that you have on your laptop and transfer it to Crane and just test this out, please do that. Alternatively, you can transfer a file from Crane to your desktop. So let's grab one and try it. Right here, the example is to grab the readme.md file from the job examples directory. So let's do that. So I run it from my laptop. So it's demo11 at crane.unl.edu. These commands will not show up in the command history because I'm running them on my laptop. Okay, so that's the source. That's what the file I want to transfer. And then the location, the target location is my current directory on my laptop. And the shortcut for that is just a dot. Okay, that's where I want it to put this file. It's asking for my password in Duo again. Okay, now if I do ls, I see this new file here that I just transferred from Crane. Any questions about that step? And then if you'd like, you could try out this as well. So if you want to copy an entire directory, not just a file, you would need the -r for recursive. So that would transfer the entire directory. So I'll just copy and paste this one to show you what it looks like. Actually, this is not correct. I'm sorry. Whoops. One sec. Oh yeah, it is. Okay, so this is a command you can run from. So you can run the scp command on Crane if you want to transfer something from Crane to Rhino. Okay, sorry, I forgot what I was doing here. So this command, I will run this on Crane. Okay, so I'm gonna transfer the Matlab directory recursively to Rhino. That's our other cluster. And where am I supposed to transfer it? Okay, just to the work directory on Rhino. Okay, so this command will show up on the command history. If I haven't done this before, it will ask me this question. I just type yes. If you've already run this command in the past, it won't ask you that. Okay, so that command should show up in the command history. As you can see, it's showing the files that it transferred. So it transferred not just the Matlab file directory, but the files that are contained in there. So if you want to try that yourself, please do so. Sometimes it's, I really like Globus Connect, but I also do use SCP fairly often. It's a you know, a great quick little command line tool where I don't have to open up a browser window to do it. So I like it. Any questions about that? Put up your green yes check mark if you are ready to move on. You've tried that and you're not having any problems with the SCP command. or if you want us to wait and answer a question for you, please type it into the chat or unmute yourself. Okay, great. We're making good time here. I'm going to talk next about transferring files using GUI applications. So you may have used a few of these in the past and have a favorite one. I'm not going to talk about the WinSCP, CyberDuck, and FileZilla because everyone might use a different one, and I'm not going to go into the details of that. But feel free to use those tools if you like. The one that we support and recommend is Globus Connect, which has some additional features that are nice, like file sharing, for example. So I'm going to talk about, we're going to do some exercises to get you guys started on Globus Connect, and then you can decide whether or not it's a tool that you want to keep using. Yeah, let's go ahead and all try it together. What it provides is fast, secure, robust transfers with a nice user-friendly web interface. And what I mean by fast is it uses our high-speed transfer nodes by default. So it's probably a little bit faster than some of the other GUI applications. It's robust in that it can handle interruptions. So if you're transferring a file from your laptop to Crane and you turn off your laptop, then turn it back on, as long as Globus, the Globus application is running on your computer, it will start up where it left off. You can transfer directly between the clusters and Attic, as well as to and from your personal machine using Globus. There is a piece of software that you have to install on your machine, on your laptop, in order to transfer to and from the clusters from your laptop. The other features that we support are file sharing. So I won't talk about how to do the file sharing, but we have good documentation on our webpage of how to do that. So for example, if I have a file or directory that I'd like to share with somebody who's not even at the university and who doesn't have an account on HCC, I can do that through Globus. There's a command line tool for people who love the command line as well, and we have some documentation on our webpage for that. So I won't go into, we won't have time to go into that, how to use it, but if you really would like to use the command line, you can. And you can do rsync style transfers as well for backups. No promises, but this should be coming soon. You should be able to transfer to and from OneDrive as well. All right, so, and I mentioned we have good documentation, so the link for that is here. But you should be able to find it easily. If you don't have this whole link, just go to our main documentation page, which is this part, and do a quick search for Globus on that page, and you'll find this. So. Okay, so this is actually, I think, my last slide, but it contains a lot of exercises. So we're going to do all of these things together. The first thing we're going to do is just log into globus.org. You do not need a Globus ID or a special Globus account with a Globus password. You can have one, and there's a way to create one, but you can just sign up with your UNL credentials because it has in common. So that's one less new password that you have to have and remember. So I'm going to open up my browser window. So everybody would want to navigate to globus.org. Normally when I go to this page and I click log in, I'm already logged in, but I cleared my browser so that I would be able to show you the process of logging in. But once you do this, once your computer will store it, and you won't have to log in every time. Okay, so this is just your UNL, not your HCC account, but your UNL credentials or NU credentials or whatever university you're part of. Actually, you don't have to have a affiliation with UNL to use Globus. You do have to have an HCC account to access your files on HCC, of course, and I'll show you how to do that. Okay, so everybody should be able to log in and see a screen that looks something like this. Okay, so the exercise is to transfer the job examples directory from Crane to Rhino. So to do that, we go to the File Manager tab, and so that's where I was, I put automatically when I logged in. And search for the endpoints. The endpoint names are HCC # Crane and then HCC # Rhino. Those are the names of the endpoints that we have. And then you will need to activate each endpoint. So you'll have to use your HCC password and Duo authentication method, which is probably your phone, to activate these endpoints. And your activation expires every 7 days per endpoint. So that's nice in a way because it's more secure than just having it never expire. But you don't have to activate constantly, right? So if you're using this to transfer your files regularly, it's only once every week that you'll have to reactivate it. Okay, so let's go ahead and do that. So I'm going to search for the endpoint. It's something I used recently, so it shows up right here. But if you haven't used it, you would type HCC #Crane, and the search will find it, and just click on it. Okay, now it's telling me I need to authenticate. I removed my credentials yesterday so that it would ask me to authenticate, so I could show you. All right, so this is my HCC account I'm signing into right now. So this is your HCC username and password. Right, so by signing in as the demo11 user, or whatever your username is, it will automatically put me into my home directory on Crane and show me what's there. Okay. Okay, and the exercise says to transfer our the job examples directory. Okay, so that's in my work directory. So I need to change this path manually to my work directory. And I could change it to someone else's work directory, but it would not give me access, right? So you can only access your own. Whoops, typo, sorry. Okay, here's the job examples directory. So I click on it, and then I click on transfer or sync to. And then it opens up another panel here for me to give the target endpoint. So the target endpoint is Rhino. So I search for that endpoint, click on it. I have to authenticate here as well. But like I said, it's just once every 7 days. Okay, so once that goes through, okay, so now it shows me it will show me in just a second, what's available or what's in my home directory on Rhino. And the exercise asks us to transfer it to the work directory. Okay, so we want to make sure we're not putting it into our home directory. I'm going to put it in my work directory, so I have to change the path here. Okay, now I make sure I've highlighted the directory I want to transfer, and then I can go ahead and click Start to start the transfer. It says, it gives me a message here that it's the request was submitted successfully. I can view the details of the transfer, which if you want to do that, you can. It'll show you if there have been any faults or interruptions or if it's succeeded. But it's probably a really quick one. So what I can do here is just refresh my directory listing here on Rhino, and it should show up there fairly quickly. Okay, so that's how to transfer between the clusters. If you have an attic allocation, you can also transfer to and from attic. So you just search for the attic endpoint. Okay, and then you'd have to authenticate there as well. Right. It's the same process, so I'm not going to necessarily show you that right now. There's a question in the chat that says, is this the method that we will use to transfer files between attic and crane as well? Yes, I just answered that. Yep, that's the method you'll use. Okay. All right, so the next example, or excuse me, exercise is for us to transfer something from our laptop, right? So you're definitely going to need that to do that at some point, probably. So what we need, the steps to do that are to install Globus Connect Personal on our laptop or desktop. So to do that, we go to Globus. If you click on like the collection here, and then it gives you this search field. And then down at the bottom right, it says, there's a link that says install Globus Connect Personal. So click on that, and then it will give you options for your operating system. So I'm on a Mac. I'm going to show you the process for a Mac. It may look different for you on Windows. So, okay, if I click on it, it says, I say to open. So it's downloading it. I drag it to my applications folder. I already have it there because I've done this many times. I'm going to replace it. So after I do this, I'm going to pause and give everyone a chance to do it on their own. So you can just watch what I'm doing now and then do it on your own in a couple minutes. Okay, so now I need to open up the application. So wherever you put it, it's in my applications folder. So I'm going to open it to run it. It's telling me it's downloaded from the internet. Am I sure I want to open it? I say yes. Okay, and then it's asking me to log in. And this is the step where it opens a browser window and asks me to give my consent. And then what it does next, and it's a little confusing, after I give my consent, it opens this pop-up window and it doesn't put it in the front. So I have to do this to find the pop-up window. So if after you give your consent, you don't see anything happening, please look for this window behind your other windows. And then I set up my endpoint name. So I'm going to call this Emily's laptop. You can give a description if you'd like. I'm not going to. And then I click save. It's successful, so I exit the setup. And then I can go back to my, I'm going to close, whoops, this keeps moving my way. I'm going to close this tab. I don't need that one anymore where I gave it the one that it opened. Now I'm just back in my regular Globus page, and I can go to File Manager, and I can enter, so either I can search for the name Emily's laptop, or I can click on your collections, and it should show up there because it's the one that I own. I'm the owner of that one. Okay, so I open it up, and it's going to show me what's on my laptop. I'm going to open the desktop because that's where I have some files I can play around with. And then I can do a transfer just like I did before. I decide where I want to put it. I think the exercise asks us to select transfer file from your computer to Crane. So I can just pick any file and I'm going to put it onto Crane. So I need to specify Crane again. I can go to recent and it'll show me Crane there. I don't have to search for it again. And I'll put it, I guess I'll put it in my home directory. That's fine. And I'm going to choose, I guess I'll just choose this README file again and click Start. And then if I go, it's a pretty small file. So if I go here and just refresh this by pressing Enter a couple times, it should eventually show up. It hasn't yet. There we go. There it is. Okay. So that's transferring to and from your laptop. You can go the other direction as well. You can select a file here and transfer it to your laptop or your desktop. Okay, so I will stop now talking and give everyone a chance to do this. If you, here's the exercises. If you didn't do number 2 yet, please do that. If you completed number 2 and you'd like to install Globus Connect Personal and try it from your transferring to and from your desktop, please do that. And we'll have the next, we'll see 10 minutes to work on this.
All right, it is now 11:05. Just to make sure everyone is already back and ready to go, could you go ahead and put up a green check mark for me? Okay, it looks like most of everyone is back. Let's go ahead and give about another 30 seconds and then we will begin. Again, for those now returning from the break, go ahead and give me a green check mark when you get back. This is just so that way we don't miss any information and everyone can get as much as they can possibly get during this tutorial. Alrighty, so earlier we talked about data storage and data transfer on Crane using SCP and Globus. Yesterday we also looked at how to submit different jobs onto the Crane supercomputer, as well as the process of creating the submit scripts. In the submit script, we had at the top our resource allocation and job specifications. At the bottom of it, we basically ran the commands to do the actual work of our job. However, we only skimmed over the part of actually loading the software for our jobs or the different applications. And so that's what we're going to be talking about a little bit here today. We're only going to be talking about the module system, which is the way to load the majority of software on Crane. In some other workshops, we have talked about things like Anaconda for Python and R. We do have some recorded videos on that from our June workshop series. I'll throw that link in the chat as we get closer to the end of the day, so that way that is available for y'all. But basically the quick way to run applications on HCC is we use a system called modules, or LMOD. And this is done because we work with thousands of different users. Not everyone is going to be using the same specific software or even software versions at the same time. And if we were to load all, I think we're at 1,300 different pieces of software and versions all at the same time, you'd basically sign into Crane and wait there for a few minutes while everything gets ready to load. And so we basically say, load what you need when you need it. Everything else can stay unloaded and sit in the background. And the way this works is by dynamically changing two different environment variables, path and LD library path, as well as changing a few other things in the background. And so that way, if you want to request, say, MPI or GCC as specific version, those are loaded into those path variables and environments for you then and there, rather than having to go out and compile the software yourself, or go out and hope you have the right version that you're looking for, that we have the right version. It also provides a nice way to help manage software that depends on each other. So if we have, say, a C function or a C code that we want to run on the cluster, and we want to have MPI with it, in order to get that code running, we need packages like GCC to compile it, as well as OpenMPI for the software library. However, in order to load MPI itself, you will also need to load in GCC. And so what module does is it doesn't try to load any modules it can't load until all dependencies are solved. So if module A or B is dependent on module B or C, then you'd have to load A or B first in order to load the other two modules. The way we like to also categorize our software is using a naming convention following the hierarchy. So for a lot of software, it's just simply the software name, like Python here at the bottom of the slide, and then the version number itself following a slash. So Python 2.7 is Python/2.7. R 4.1 is R/4.1. Some other softwares are categorized with another item, like GCC has compiler. So it'd be compiler/GCC/10.2, I believe, is a version we have available. And like a lot of the things with the cluster, this is done through a command called module. So if we scroll through, there's really only 6 commands you need to know to be able to use software on the cluster. The big one is going to be module avail, which is listing all the packages currently installed. We have a web interface version of this, since that's oftentimes a little easier to scroll through or find things. Module spider is used to search for specific modules. So if you want to see what versions of Python, R, OpenCV, or MPI are available, you basically would go module spider, OpenCV, or Python. It is indeed a weird naming convention in that you'd expect it to be module search. Module spider to me makes sense in that you're going through a web of different packages, so it's a spider crawling across its own web. To load and unload software, it's simply module load in the package name or version. So module load Python 2.7 or module unload Python 2.7. To unload all modules, so if you're done with modules in a job, you can purge them away, and it just unloads everything. And then finally, module list is basically a list of all the currently loaded modules. We're actually going to dig into playing with these commands, experimenting with them as well. Just like we discussed yesterday, a lot of commands will have the nice and helpful --help. Module certainly has that available as well. But if we kind of go through our lists here, and let me go ahead and reshare my screen. Let me go ahead and new share. So this is a list of all the different pieces of software that we have available. So if I select all rows here real quick, we have 1,371 different pieces of software or different versions of software. It's just a very long list that you can go through. If we go ahead and scroll all the way back to the top, you also have the ability to search for our different application packages. So if we want to see OpenCV, can easily see all the versions here. If we want to go for just simply R, it's going to try and load everything with the letter R in it, unfortunately. So let's try Python. So we have BioPython, we have Gabori Python, and regular Python. So kind of just a variety of things there. This is also going to be available through the command line. So let's go ahead and go back to the PowerPoint. Now I'll go ahead and throw this link quickly in chat for everyone. So we're also going to do some quick exercise here. So let's go ahead and go to our terminal. Share, demo, sure. So just to double check everything, can you give me a green check if you're still signed into Crane? And can see your command prompt or terminal? Perfect. Now I'm going to make this a little bigger so it's easier to see. So the first thing we're going to do is we're going to go ahead and go to our work directories. If you were following along on the last exercise, in theory you should be there. But we're going to go ahead and switch to work. And then see what we have in our folders. So right now work directory is fairly empty. If we want to take a quick look at what modules we already have loaded, we can go ahead and type module load, or sorry, not module load, module list. And this will list everything that is currently available. So we have the GCC compiler, OpenMPI, Python 3.8, Perl 5.26, Git 2.3, and Nano, a text editor 5.7. By default, these are the modules that we have available, just automatically loaded for you when you log in. This is just because these are some of the common tools that a lot of people use when they first sign in. It makes it a lot easier to just keep these loaded at all times than to constantly have to go and load, say, Nano just to have a text editor if you want to make a quick change to a file. What we can also do is go and look at all the different software packages available. So if we do module avail, it'll take a quick second to load. But these are all 1,300 different software packages we have available to us to load. So if we hit spacebar to scroll through it, it's a very long list. You may be noticing that these D characters on the side, these basically just represent what the default package or module will be if you just type module load in the software package name. So if we were to type, say, module load nextstrain CLI, it will by default choose this version of 3.0 rather than try and use 1.16. Commonly, it will be the latest version will be the default version. However, not all the time the latest version will be what you'll want. And so we typically will try and keep it at the most stable version or the most supported version. So say if nextstrain comes out with 3.2 and we load that in and it's not necessarily going to be beneficial to have it be the default, 3.0 would still be the default, but 3.2 would still be the option to have loaded. To exit out of this command, you can press the letter Q, and we have our terminal again. You can type. So let's go ahead and do load, say, what would be a good package? Let's do metacv. So to load a module, it will be a quick load command of module load metacv. And then the current version we'll use is /2.3. If we type in module avail, I'm sorry, not module avail, module list, we can now see that we have metacv 2.3 available. Sure thing. So there we go. Something else that we may have, something else that you may have noticed when we go back to module avail is this section up here where it's saying GCC 10.2 plus OpenMPI 4.0, or just simply GCC 10.0 or 10.2 modules. This goes back to the idea of the whole hierarchy idea, where some modules are required to have some prerequisites or dependencies to be installed or loaded first. And so these are the different modules that are available now that we have GCC 10.2 started. We also have these extra ones now that GCC 10.2 and OpenMPI are loaded as well. So if I quit again with the letter Q and clear the terminal real quick and type in module purge to completely unload everything and do module list, we can see that we have absolutely no modules loaded. If we were to try and run the nano command real quick, you would see that it's not found anymore because we unloaded it. If we go back to module avail, let it load for a second, we can see that we no longer have that little header saying GCC 10.2 or GCC 10.2 plus MPI. So those dependencies are no longer resolved. I'm going to hit Q again to go ahead and exit and clear out of the terminal. We can also look for software packages that may be interest. So if we want to say find PlumeMD, what we can do is do module spider and then Plume or PlumeMD, I think it's what's called, or PlumeMed. Nope. Module spider. There we go. So it's PlumeMed. So this is kind of the quick information that you'll get from looking at a module spider. We can see a quick description of the software. We can also see what versions are available. So we have 2.5 and 2.7 available for us to load. We can also look at some extra information about it, which we just did. If we want to load it, we can go module load Plumed /2.7. It'll take a second to load. And here we have a quick little error. And so it says these modules or extensions cannot be loaded as requested. And so it's telling us to look back up here to figure out what we need to do. Oddly enough, it doesn't show what is needed to be loaded in this case, but it's missing both GCC and MPI. So let me go ahead and clear again. So if we module load compiler /GCC /10.2 module load OpenMPI /4.0 and check out what we have currently loaded. We now have GCC and OpenMPI loaded. And if we switch up real quick, we should be able to load Plumed 2.7 because we have resolved dependencies. I'm not sure why I didn't list these in module spider earlier, but these are the common two ones missing for Plumed. If we go ahead and do module list once again, we can see Plumed is available. Something else we can also go and do is try. Actually, we can probably go ahead and start our exercise here real quick. So let me go ahead and switch back to the PowerPoint. So this was a very quick, I guess, introduction to it. Are there any questions before we start our exercise or any concerns? Or would we like to continue? So red X for a question, green check for continue. That was kind of a fast introduction there. Okay, so I see a few green checks. Do we have any questions? If you do, feel free to mic up. That's kind of a lot in a little bit of time. Okay, so let me go ahead and switch over to the exercise. So What we're going to have you do today is you're going to start off with looking at a list of available modules. Are we going to cover? Are you going to cover the DMTCPH batch file process today? I am not sure entirely what that is. I'll look into that while everyone works on the exercise, though. Going back to the exercise, you're going to load one or more modules from the list you just found. You're also going to practice unloading the module. You're going to try it in different ways as well. Then you'll look at the QIIME2 module. You're going to look at how many different versions of the module are available and load a specific version of it. To add on to this, and I'll put it on the slide here in a second, I'd like you to also put in chat of how many versions you found and which version you loaded. Now, after that, you'll go ahead and learn the meme 5.1 suite 8. Just look if it worked or not. Compare that if you load in these two software packages and reloading it again. And then I want you to unload all of your modules with one command. You're going to have about 10 minutes for this. So we'll get back at about 11:35 to finish up this exercise, and we'll go through it together. So we're going to go ahead and run through our exercise here real quick. So for step 1, we're just going to take a quick look at all the available modules with module avail. We can scroll through with the spacebar to kind of scroll down. Go ahead and push Q to exit and go clear the terminal. I'm going to go ahead and load some modules I commonly use, which is going to be module load, Python 3.7, as well as module load Anaconda. So these are two common software packages I end up using almost every day. If I do module list, we can see that those are indeed loaded along with QIIME that we just tried to load. I can get rid of those using module load, Python and Anaconda, QIIME2. If we do module list, those are module list. We can see none of those modules are loaded anymore. For step 3, if we go and look at the available modules for QIIME, so module spider QIIME2, we can see that we have 8 different versions of QIIME2 available for us. So let's go ahead and load 2018.2, for example. So module load QIIME2/2018.2. It's going to take a good second to load in just as it does its process. We can verify that using module list. And we have 28.2 or 2018.2 installed and ready to go. Let's go ahead and try loading that meme suite software. So module load meme suite 5.1 and hit enter. Looks like we are missing some things here, so let's go ahead and copy that and clear the page. And if we do module spider to get some extra information for meme suite 5.1, we can see that we need to load these two packages here in order to get it to work correctly. So if we do module load compiler GCC for version 9.1, and if we load open MPI 4.1, or sorry, not 4.1, 4.0, then if we load in the meme suite 5.1, once again, it should in theory work. And there we go. So we have the module fully loaded here. We have meme suite as well as some other software packages loaded to get it to work. Now we can go ahead and unload everything with module purge. Module purge. Clear and do module list. Let's not forget the space. We can see that we have cleared everything. So I'm going to go ahead and switch back over to the PowerPoint so we can go through our one last thing, and then we can wrap up for the day and do some questions. So 1,300 or 1,371 packages is all great and dandy. There's a whole bunch of different software versions available, but what if you want to use something else that we don't have available? This is a very great question of, well, there's many ways we can go about that. You are allowed to and encouraged to install your own software yourself on the cluster. You can do this by compiling the software from source. So if you go to GitHub, for example, you find a software package you need to use. You can clone the repository to your home directory and build it with following the instructions from the repository. Then you can use it yourself in your jobs. Another option is to use Anaconda Environments, which are great for working with Python or R, where you have a whole variety of different library packages like pandas, NumPy, Matplotlib, TensorFlow, etc. And then if you need something a little more advanced or configurable, an option is to use and create Docker containers or Singularity images to then run on the cluster as a job through Singularity. If that's not going to work too well for you, you can certainly ask us to install the software itself on the cluster. We have a simple little request form that basically you ask what software you want, where we can get it from to install it, if there's any licensing, what it is, why you'd like it installed on the cluster. That's how good a majority of the software was installed on our cluster from in the beginning, was just a lot of requests being installed. And we typically try to get this done as fast as possible, where if it's something simple, we could probably almost do it the same day or next day, depending on how many requests we have. If it has a lot of dependencies into the double digits, then it can probably take a lot longer. Or if it's a software package not designed to work on a cluster environment or on Linux, then it's going to even take longer. It just kind of depends on a whole lot of different variables. That's kind of the end of everything for today. Are there any questions or concerns or comments? And we do have a few things to also take care of at the same time. So let's go ahead and copy this. So as I mentioned at the beginning, I would also post the tutorial from Anaconda from our June workshop series into the chat. We also have the sticky notes survey that we've been filling out the last few days just to get some feedback on the workshop. If you could take the time to fill that out. While you fill that out, feel free to ask any questions. I will go ahead and stop the recording here.